Whole input layer, hidden layer 1, hidden layer 2 and the output layer. So for input layer, the neurons in the input layer does not just this will hold the values only. For example, it will give the data points x1, x2 and so on. These are also neurons. Each circle represents the neuron. So input layer neurons does not help anything. It just hold the data points. Hold the data points, no computations. No computations at input layer neurons. In this neural network, there are two hidden layers, one input layer and one output layer. So, for example, in the number of neurons in the input layer is n, in the hidden layer 1 is p, and hidden layer 2 is q, and output layer these are k. For example, it is a classification problem. There are k number of classes. So first we give x. X is the data. So for example, the data belongs to r power n. That is, the dimension of the data is r power n. If it is 2 dimensional, x r power 2. That is, x is belongs to 2 dimensional. So there are 2 number of neurons in the neural network. If it is n dimensional, n number of neurons in the input layer. For example, layer, the output is represented with y. Y is the output predicted by the neural network, and the output layer is a classification problem. It contains k number of classes. So there are the output of the each input is belongs to the one class only. Okay, and the output layer consists of k number of classes. That is, output layer consists of k number of neurons. And just hidden layers are used. Hidden layers generally is used to handle the number of hyperparameters. So how many hidden layers? If more number of hidden layers is increased, it is very good to compute the complex computations and patterns. To find the patterns, to find more patterns, more layers is good. But the number of hidden layers is depends upon the designer. He can decide how many hidden layers we can include in this neural network. It depends on the designer. It is a hyperparameter. The number of hidden layers is a hyperparameter. So to learn more complex computations, hidden layers and output layers are useful because they are using the activation functions. Activation functions introduce the non-linearity in the network. Introduce the non-linearity in the network. Okay. So if the data is n-dimensional input data, always it holds n nodes or n neurons in the input layer. N nodes, n neurons, that is, n is the features of the data. N is the features. Okay, next, each hidden layer. So there are weight matrices. The parameters of the neural networks are weight and bias. So find the parameters of the neural network means to find the weight and biases of the neural network. Whereas in the back propagation, we find the gradient. So we find the gradients in the back propagation. By using the back propagation, the loss is reduced. Okay, the weight, the parameters weights in this layer is W1, this layer W2, this layer is W3. These are matrices, weight matrices, and the sizes of the weight matrices. W1 is input output layer size. For W1, this is the output layer, this is the input layer. So output layer size is P cross input layer size is N. For W2, output layer size is Q and input layer size is P. Q cross P, number of elements in the W2 weighted matrix. And W3, the number of neurons in the output layer is K, that is K cross Q. All these are weighted matrices. In the neural network, there are activation and pre-activation functions. So here A1, A2, A3, A1, A2, A3 are the pre-activation functions. H1, H2, H3 are the activation functions. So HIR activation, AIR pre-activation functions. And what are the sizes of the AI and HI? So HI size is, H1 size is the number of neurons in the hidden layer 1. So there are P number of neurons, so P cross 1. And H2 equal to number of neurons in the hidden layer 2, that is Q cross 1. And H3 is the number of neurons in the output layer, that is K cross 1. So output of the neural network is Y, which is equals to H3 also. H3, very important, remember, output of the neural network is Y, which is also H3, this one. And input Xi equals to H0. So this one H0, this one Xi, H0. These two are matrices. So W1 equals to W1, all are starting with W1 only, that is layer 1, right? W1, all are starting with W1 layer 1. If it is layer 2, W2, layer 3, W3. So what is the size of W1? W1 size is P cross N, that is P cross N. So in the every row, the second element is common, 1, 1, 1, 1, 2, 2, 2, 2. So how many rows? So here P is rows, columns, right? For example, every matrix 2 cross 3 means 2 rows, 1 row, 2 rows. Columns is 3, 1, 2, 3, 1, 2, 3. So 2 rows, 3 columns, like that. Rows, P number of rows, that is number of row is common, every row, that is P1, W1P, W1P. Here P is common. First one W1 is common. W1 is common because of the layer 1. So next one is common, row 1. Next you can add first neuron, second neuron, third neuron, and so on. How many number of neurons? N number of neurons, that is columns. Here last columns, N. 1 neuron, second neuron, third neuron, first neuron, second neuron, third neuron. This element, what this W121 represents? W121. So first W is 1 is layer number, layer 1 weight matrix, layer 1 represents, and second 2 represents output neuron. Output neuron number is 2, and here last represents the input neuron. Input neuron number 1. Example we consider. So in this layer W1 first one is this one, layer 1 represents. Next output neuron is second neuron. So this one is first neuron, first neuron and second neuron. Second neuron, this one. Output neuron, this is output. Next this one is input neuron is 1. This is first one. That is the weight connected to first neuron to second neuron. This value is W1 to 1. Understood? W1 to 1. This value is first layer W1 and first neuron output neuron 1 W1 and the first input neuron W1. This one. Understood? Like this. These are the elements or weights of the weight matrices. W1, if they are asking find W112, that is in the first layer W1 is connected to first neuron to second neuron. So this one is W1 first layer and output is first neuron. Output is first neuron, this one first neuron and input is second neuron, this one. This value they are asking W112, like that. Okay. W2, why these are useful? These are useful to connect the layers, one layer to this layer to this layer to connect. Weights are connecting the neurons from what they connect neurons from input layer to output layer, that is previous layer to next layer. These weights are useful to connect the neurons. Site P cross 1. So what are the elements in the first layer? So for example, this is the hidden layer 1. So here H1 is there. What is the size of the hidden layer 1? That is H0, first layer, right? First layer H1 0, sorry, H11, H12 and so on. How many neurons in this layer? H1 hidden layer 1, P number of neurons, that is H1P. H1P, that is P cross 1 and H2 equal to second layer, right? Start with 2. H21, H22 and so on. How many neurons in this second layer? Q number of neurons, that is Q cross 1 and H3 equals to starting with 3, H31, H32 and so on. K number of neurons, that is output classes, H3K, K cross 1 equals to A11 and so on, A1P. In the same way like A1, A2 and A3 also. So H1 is sigmoid of A1. If they are hidden layers using sigmoid activation function, if they are using tan H activation function, H1 equal to tan H of A1. If they are using ReLU functions, H1 equal to ReLU of A1. In the same way, H2 equals to sigmoid of A2. Output Y equals to output, sometimes they represent with Y or Y hat also. Y hat equals to, in this problem we are using softmax activation function. It is represented with circle, that is softmax of AL. For example, how many layers? L is the fourth layer, A4. L is third layer, A3, which is equals to, if it is 3 layers only, 3 layers, input layer, hidden layer 1, hidden layer 2, output layer, that is softmax of A3, which is equals to H3. Here they are using softmax classification problem. So in that time, softmax function is represented with softmax of, for example, softmax of A3 equal to A31, A32, A33. That is third layer, right? A3 equals to third layer vector. So that is the softmax of A3 equals to, that is softmax of A31, A32, A33. How to write softmax function? That is H3 equal to softmax of A3 is equal to e power A31 by e power A31 plus e power A32 plus e power A33, and e power A32 divided by e power A31 plus e power A32 plus e power A33. So e power A33 divided by e power A31 plus e power A32 plus e power A33. This is the softmax. So number of classes equal to k cross 1. So if these all values are same, for example A3 has all values are same, 1 1 1, all values of 1 or any constant value a or k or x, any values x p or p. So that time e power p by e power p plus e power p plus e power p, that equal to e power p by 3 e power p. E power p if you ever cancel 1 by 3, that is 1 by 3 for this element 1 by 3 and this element 1 by 3. It is a matrix size of 3 cross 1, that equals to the size belongs to this value. All these are softmax, right? Probability values. Sum of these all values is equals to, very important, some questions are based on these values also. This sum without calculation you can write sum. If they mentioned in the question, if the output layer uses, very important, if the output layer uses softmax function, the sum of all values of the output matrix of the output y of the output matrix or y is 1, because it is a probability matrix. If we sum all the values, 1 by 3 plus 1 by 3 plus 1 by 3 equals to 1. Very important. Without calculation you can remember, if they are asking sum of all the elements in that matrix, sum of all the elements in this matrix, you can write answer as 1.0 or 1, anything. Okay, every time they are asking cross entropy loss. So the cross entropy loss CEL equals to, the formula is minus y ln of YL hat. YL hat is the true label. If all the derivations are given in the lecture, sometimes cross entropy loss L equal to minus ln of YL hat, because y value is 1. Algorithm GDA to update the parameters WI, weight and bias to update. First we randomly initialize the parameters. How do we update the parameters? WT plus 1 equal to, in the next iteration, WT minus eta times delta W with respect to loss derivation. This is the gradient descent rule. Eta is the learning rate. This is the gradient of the loss, derivative of the loss with respect to weight matrix. Okay, by this using chain rule, use chain rule to solve these values, which are generally referred to the back propagation. So if they are asking gradients to calculate delta W310 210 like this, these questions are related to back propagation. So how to find the output of the neural network? Y hat. So if it is a classification problem, softmax is used at the output layer. If it is a regression problem, linear function. So linear function for regression. If it is a classification, we use softmax activation function. Softmax of AL minus 1. A equal to W H plus B. Always reduce minus 1. All this, if it is 3, W3, P3, minus 1 is 2. That is reduce one value to the H index. That is differentiation of this loss function minus ln of L hat with respect to AI. That is dou L by dou AI. So very important. Remember what is they are asking in the question with respect to differentiation with respect to A. Okay, that is represented with delta L of AI. Delta L of AI. That is generally A is in terms of WH plus B. If they are asking with respect to A, write in terms of W and H. Sometimes B is 0, bias is 0. So if they are asking with respect to A, the other parameters are 3 parameters, A, W, H. If they are asking W, write in terms of A and H. If they are asking H, write in terms of A and W. If they are asking in terms of A, write in terms of W and H. So dou L by dou A equal to H in terms of del HI had mod product of sigmoid dash of A. See, this one is element wise multiplication. Element wise multiplication is dou L by dou HI. If we are differentiation with respect to H, that is they are asking H in terms of A and W. In terms of A and W. So that is W transpose I plus 1. Here it is I plus 1 times delta A I plus 1. So delta L with respect to Wi. So Wi A and H. A and H, that is equal to delta L with respect to A and H, right? Dot H transpose I minus 1. Always H index is less than 1. Dou Y hat. So differentiation of loss with respect to Y hat output, that is minus Y by YL. So what are the Y values? Y is 1 hot encoded vector. Y value is true value. True value, that is 1 hot encoded vector. And YL is the probability for the true class. So in Y hat or Y, there is a matrix. For example, 1 by 3, 1 by 3, 1 by 3. That is the probability for the true class. Based on the true class, we consider only one value. Some with respect to AL or AI, anything equals to y hat minus y. Which is equals to delta A. Delta A of L. Loss value. That is gradient of the loss. Gradient of the loss with respect to pre-activation function. Y hat is the predicted value, predicted output. And sigma of z, remember these two also, sigma of z equal to 1 by 1 plus e power minus z, and sigma dash of z is derivative equals to sigma of z times 1 minus sigma of z. These two, dou L by dou A3. So in this question, here I equals to 3, right? Dou L by dou A3, that equals to y hat minus y, that equals to delta L A3. Dou L by, so dou A3 equals to delta H3 had mod product of sigma dash of A3. This is the derivative of sigmoid function. So how to write sigmoid of A3 here? Sigma of A3 times 1 minus sigma of A3. So delta H3 equals to, so in this one, write I equals to 3. So dou L by dou H3, that is delta L with respect to H3. So Wi plus 1, W4 transpose delta A 4, delta 4 T transpose delta A4. So W4 transpose delta A4. 4 times had mod product of sigmoid of A3 times 1 minus sigmoid of A3.